Someone's requested by email that I do this question, C2 June 2009 question 6, and the first part A, I've got to find the radius and I've got to find the centre of the circle. And to start with, this doesn't look like a circle equation, so just to remind you, I'm going to put the circle equation down here. Okay, and that's where A and B is the centre of the circle and R is the radius. Okay, to get this to work, I need to collect the things with x's in it to one side, so x squared minus 6x, put the y things together, 4y equals 12. And then I'm going to complete the square on this bit here, which will give me x minus 3 squared minus 9. Notice that when you square minus 3, you get plus 9, so it's always going to be a minus 9 here. Okay, and so that was that bit. Complete the square on this bit, and then this bit here, okay, is going to become y plus 2 squared minus 4, and that's the first bit. So then we've got these numbers that are in the wrong place, so I'm going to push those over to the other side, and that will leave me with x minus 3 squared plus y plus 2 squared is equal to 25. 12 plus 4, 12 plus 9. And we can see then the centre of the circle is 3 minus 2, and the radius equals 5. In part B, we're given 2 points, P and Q, and we're told that P is this coordinate and it lies on the circle. Given Q is that point, it lies on the circle. And whenever I'm doing coordinate geometry, I find it really useful to do a sketch, to try and visualize what's going on. And it might be obvious to you that if the midpoint of anything that was a chord, okay, would never be the center of the circle. Okay, so we can prove that P and Q is a diameter by showing that the midpoint of that line is indeed the center of the circle. Remember, in the previous question, we calculated that the center was 3 minus 2. So what we're going to do is calculate the midpoint of PQ, and if it's the same as the center of the circle, then we've proved that PQ is diameter. So let's do that. So let's take the average of the x. Well, first of all, we can just do it commonsensically. You can see that if I'm traveling from left to right, -1 to 7, I must have travelled 8 across. So if I travel halfway, that would take me to 3. And if I've gone from 1 above sea level to -5 below, so I've gone 6 down, haven't I? And that would mean travelling 3 down, which would take me to -2. But because this is a proof, I think I need to show a formal equation. And so I'm going to show that the midpoint, okay, the midpoint x is the average of the x coordinates, and that does give you 6 over 2, gives you 3. And if I do the midpoint of y, then I've got 1 plus minus 5 over 2, and that does give me -2. And I can say as midpoint of P and Q equals center of circle, okay, PQ must be diameter. Now in part C, they've given us that the line PR, okay, is perpendicular to the line RQ, which means that's 90 degrees. They've actually been kind of nice, actually, because they could have not told us that, because we are actually supposed to know that as we've just proved, PQ is diameter, any angle in the semicircle equals 90, so they didn't necessarily have to tell us that. Okay, but it means that line PR is perpendicular to line RQ, which means that when you multiply their gradients, they should equal -1. So what I've done is, we know that R, because R is on the y-axis, we know that its x coordinate must be 0 because you're not to the right or to the left. So the only sort of unknown thing here is this question mark for what the y coordinate is here. And I'm going to just call it y, so we'll just call it y. So the gradient then, the gradient of PR is y2 minus y1, so y minus 1 over x2 minus x1, which gives me this. And if I do minus minus 1, just gives me y minus 1 over 1. The gradient of the other thing is gradient of RQ. It's going to equal y2 minus y1, so minus 5 minus y, so minus 5 minus y, and x2 minus x1, so that's 7, okay, take away 0, and they're the two gradients, so this obviously just simplifies to minus 5 minus y over 7. And so there's various different ways. You can either just think of that this one is the flip reciprocal, negative reciprocal of this, or that these two multiply together to give you minus 1. So I'm going to show that as this. So y minus 1 over 1 is equal to this one, okay, times by minus 1. Well, actually that's a mistake because I've forgotten to flip this. So I need to flip this. So it's 7 over minus 5 minus y. Okay, so what I've done is flip this one and multiplied it by minus 1. Okay. And we need to get rid of these fractions. So if I get rid of these fractions, I tend to just multiply the fraction away. So in my mind, what I'm doing is multiplying everything by minus 5 minus y on that side, and doing the same on this side. And what this will give me is y minus 1 and minus 5 minus y equals minus 7. Here we just had the 1, here we just had this multiplying up there, and when I multiply out this bracket I get 5y, sorry I just moved this up so you can see it better, I get minus 5y, that times that, this gives me minus y squared, this gives me plus 5, this gives me plus y equals minus 7. Then to make sure that the quadratic stays positive, I'm going to move the y squared over to here. Here I'm going to get 5 come over to give me minus 12 here. And I've got minus 5y and plus minus 4y, and minus 4y comes over to give me plus 4y here. Now at that point you could use the silver calculator, but it does factorize quite nicely. Because you're going to get y plus 6, y minus 2. Here you can see you get y squared minus 12 at the back plus 6y minus 2y. Yes, that works. So y, according to this quadratic, equals minus 6 or 2. Now, as we're dealing with lengths in the real world, there's no such thing as a sort of a minus length here, or on this particular example, so we can ignore the minus. We can ignore the minus 6. So my answer is that the coordinates for r, okay, is that r is equal to 0 and 2.